Attendees are in listen-only mode.
Good afternoon and welcome to the PASS Database Administration virtual chapter meeting today. Our topic is working with very large tables like a pro in SQL Server. This is part one of a two-part lecture with Guy Glancer. My name's Julie Blomquist and I'm a volunteer for the virtual chapter. The second part of the presentation will be on August 9th at noon Mountain Time. Please join us for the second part of this presentation. As I said, we are part of the PASS organization. There's a Business Analytics Day coming up on August 1st over in San Diego and other items as well. You could register at passbaday.com and be able to attend the conference. For a limited time, there's a discounted rate of $475 for the conference. PASS Summit is the largest SQL Server conference. It's going to be October 31st to November 3rd in Seattle, Washington. It has multiple tracks and is for developers as well as database administrators or managers. If you use the code VC15FPS6, you will receive a $150 discount for your registration.
Julie?
Yes.
We still see your first slide.
So I don't know why it's not advancing. Do you see my second slide now?
Yes.
Okay. So here's the information about the business analytics. Here's the information on the PASS Summit.
No, we don't see. We see that. We see the slide about PASS is looking for visionaries. It's not in presentation mode.
It's showing Microsoft PowerPoint. I just say start the slideshow from the beginning or from the current slide. So is that the PASS Summit slide?
Yes, but it's not. We see the old desktop.
You see this. How about now?
Yeah, much better. Great.
Okay, we are. Do you see the GoToWebinar control panel?
I see the slide about the PASS virtual groups.
Okay, we're part of the PASS virtual chapters, and there's quite a large number of them. You can take your PASS membership. Oh, great. Okay, do you see the directors at large?
Yes.
Okay. You could take your membership and associate with any of the virtual chapters, and you get emails about the meetings which are upcoming. The 2017 PASS Directors at Large elections are coming up. If you're interested in running for a seat, please contact the governance at pass.org. There are 3 seats up for election for the 2018-2019 term. PASS is looking for visionaries to also serve on the PASS board. It's what you'll be doing is collaborating with industry experts, building the future of PASS, and fostering a community of professionals. SQL Saturdays are one-day mini conferences. They're held throughout the United States, Canada, and throughout the world. It gives you a flavor of what the PASS Summit might be, because they're a mini one-day conference. The fees are usually very reasonable, just covering the luncheon costs. PASS has in-person meetings, local chapters, as well as the virtual chapters. So if you go through your PASS account, you can do a search and see if there's any local chapters in your area. If not, you might be interested in working with PASS to start up one, or sign up and attend the virtual chapters. A lot of the physical chapters also do record or have LinkedIn or the meetings broadcasted. So you might also sign up with a local chapter close by and be able to ask questions. Volunteering with PASS, there's quite a few opportunities. You could send an email to the volunteer you can do volunteering at SQLPass.org, and volunteer recognition at SQLPass.org is for the Outstanding Volunteer of the Month. You can make recommendations and submit people for that. If you discovered this virtual chapter on YouTube, please visit the SQLPass.org and become a member. It's free. You could join lots of the virtual chapters and be able to download the supplemental materials and the scripts. There are many ways to stay connected with PASS. So we have Guy Glancer today. He's a data platform MVP. He is a leader in the Israeli PASS local chapter and also the CEO and founder of Madeira Data Solutions. His career has been focused on the Microsoft Data Platform for the past 20 years, performing various database roles as either an on-site DBA, an external consultant, or a speaker. Guy is involved in many activities in the Microsoft Data Platform community. He occasionally speaks at community events such as PASS Summit, SQL Bits, SQL Saturday, and user groups around the world. He also co-hosts the SQL Server Radio podcast. So Guy, I'm going to pass the presentation over to you.
Excellent.
And I see your opening slide.
Okay, great.
This is being recorded and it will be posted on our archive of the DBA Virtual Chapter website. Thank you. Guy will be having stopping points throughout his presentation. So if you have a question, please type it in the question window.
Great, thank you, Julie. And hello, everyone. So I'm Guy, and we're going to talk today about how to work with very large tables like a pro in SQL Server 2016, but not only 2016. I'm going to talk about new features in 2016, also some new features in 2014, and features in general in SQL Server that we can leverage in order to work with very large tables. Learning from the past, we decided to do it two-part series, 2 sessions. Usually when I speak, I have lots of topics to share and lots of demos to show. And I always find myself running very, very fast to keep it on time. So this time we're going to have enough time. I'm going to have enough time to show you everything to show, and we'll have time for questions. So today is part 1, and we'll have part 2 on August 9. So Julie presented me already. I just want to say about the SQL Server Radio podcast. If you haven't tuned into SQL Server Radio, then I invite you to go to SQLServerRadio.com and join the podcast. Me and Matan Jungmann, my colleague, we release a podcast every 2 weeks. and we talk about everything around SQL Server, about our own experiences. We have some guests that we interview once in a while. We talk about community events, new feature, new releases, everything around SQL Server. So if you're into SQL Server, and I guess you are if you're here, this might be of interest to you. So again, the agenda for today, working with very large tables like a pro in SQL Server 2016. First, I'm going to talk about what a very large table is, what it means, what counts as a very large table, what it means to work with a very large table. There are all kinds of aspects of working with very large tables, and not just working with them, but doing it like a pro. So this is where we're going to talk about all the features of SQL Server that we can leverage to do it like professionals. And like I said before, I'm going to talk about a few of the new features in the recent versions of SQL Server that we can leverage. So let's start with what is a very large table. For example, is this a very large table? Let's say it's a 5 gigs table. Is it large? Is it considered large? What about this one, a 5 terabyte table? So of course, the right answer is it depends. Okay, this is always the right answer to any question, I think. And my definition of what a very large table is a table that requires special care. Meaning, if I'm a DBA and I have my database and I have all kinds of tables and I do things in a certain way, okay, I have some processes and operations to back up tables or databases, to rebuild indexes, to query the tables, etc. If at some point the table becomes, one of my tables becomes so large that my current processes and operations are not good enough, I need to do something else. I need to acquire new skills. I need to use new tools in order to cope with the size. This is the point where it becomes very large, because for one person in one environment, 5 terabytes table might be considered very large, but for another environment, another person, this might be considered a small or a medium-sized table. Where we can use the same processes, the same tools, the same skills to do everything like we do with the 1 gig table. So, for the sake of this demo, what I mean when I talk about very large tables is a table that has a date time column, and it's an ever-increasing column. So we have lots of inserts into the table with a date time column increasing all the time. And it's a kind of an activity table, a log table. I think every database has such a table. Even if it's a data warehouse, it would be the fact table. If it's an OLTP database, it will be something like page views, messages, measures, events, transactions, something like that. I think you know what I'm talking about. Those are the fact tables, the main operational tables in most databases, and they become very large very fast. So for the sake of this demo, I'm going to use page views table. Let me switch to Management Studio. So I have here my very large table demo database with a few tables, and the main table is the web page views. So it looks like this. Okay, a very simple table. I have an ID. It's a sequence. I have a URL, as you can see, very meaningful URLs. Some reference code, some session ID, and of course the date and time, which is ever increasing. And currently this table holds 5 million rows. Again, 5 million rows can be considered very large, maybe not. For the sake of this demo, we're going to consider this table as a very large table. And that's it, that's my table. So the entire demo is going to be with this table. So this much for the definition. What do I mean when I say work with very large table? I'm going to cover 4 areas of how to work with very large tables. First is how to manage the table. By managing the table, I'm talking about the data, where do we store the data, and how do we move data around, mainly about archiving all data or deleting all data, stuff like that. Of course, we're going to talk about partitioning. Then we're going to talk about how to query the table. So when a table becomes very large, there are some challenges regarding query performance. And we're going to talk about some features and things we can do in order to improve performance of our queries against a very large table. I'm going to talk about update the table, not specifically the update statement, but meaning changing data, inserting, updating, deleting, mainly inserts. I think that the most challenging part about very large tables is the rate of inserts. And we're going to talk about the throughput. How can we increase the throughput and insert rows into the table faster? And the last thing is how to maintain the table in an efficient way. And when I talk about maintenance of tables, I talk about rebuilding indexes, update statistics, backups, stuff like that. So again, when a table becomes very large, it becomes more challenging to do maintenance. So we're going to talk about some features and processes to do that. So those are the areas we're going to talk about. And let's start with managing the table. So back to the demo. So what I'm going to do now, I'm going to start with the metadata query from syspartitions. I want to show you what's the current state of the table. So currently we have a single partition. The table is not partitioned. We have a clustered index on this table. It has a single partition. As you can see, we have around 5 million rows at this point. And of course, one of the first things we should do with very large tables is to partition the table. The better way is, of course, to plan in advance, design the table in such a way that it's partitioned before we start using it. But even if we have already have a very large table, we can still partition it, and I'll show you right now how we can do this. Of course, partitioning is a feature that has been around in SQL Server since 2005. There are some advancements, some improvements. I'm going to talk about some of them later on in the recent versions. The reason we want to partition very large tables is not because we want to improve query performance. This is some common mistakes that people do. Partitioning is not meant to improve query performance against the table. In fact, in some cases, it might even degrade performance, and we need to be aware of that and understand how to do things, how to query such partition tables. The main reason for partitioning very large tables is to improve the management of the table, and mainly the archive process, the sliding window. So let's say we have some regulation and we need to keep the last 7 years of data in the table. If we have more than 7 years of data, we need to archive or maybe delete the 8th and the 9th and all the data before the past 7 years. If we don't have a partition table with just one single partition, then archiving, moving the data away is going to be a heavy operation. It's going to be complicated to accomplish that. We're going to have to implement some kind of a looping mechanism to do it in small chunks so that we don't lock the table for long periods or blow away the transaction log file. So when it's partitioned, it's going to be much easier. And I want to demonstrate how to do this here. So I'm going to take this single partition table, and I want to partition the table based on days. So each day will have its own partition. So first, what I need to do is to create a partition function. And I have a script here that does this dynamically. I already have, I didn't say this before, but I have 6 months of data, around 180 partitions of data, or 180 days of data currently in the table. So I want to split it into 180 partitions. I can do it manually. I can do it inside a loop or something like that. Here I'm going to do it using dynamic script. I'm going to add to the script 181 boundary values. Okay, starting from actually tomorrow, going backwards 181 days. Once I'm done with that, let me execute the script. Okay, so basically I have the last 180 days plus one empty partition for prehistory. So everything before 180 is another partition, and one empty partition for the next day, for the future, actually, for everything starting tomorrow going forward. So I have a partition function. The partition function is independent. It doesn't it still has nothing to do with the table itself. Okay, I still need to connect between them. Next, I'm going to create a partition scheme. The partition scheme maps each partition to a file group in the database. So here I can basically I can say that each partition goes to a separate file group, or like I did here, all partitions will go to the primary file group. Okay, so I'm not using file groups in this demo. It's possible to use different file groups and maybe to put them on different locations, different disks, different devices. And this is something that maybe it's a good time to talk about storage tiering. Okay, so one of the things we can do when we use partitioning is to put the recent partitions that we use heavily on fast storage, SSDs, for example, And the cold partitions, the ones from the past that we access rarely, we can put on different slower storage. We can do this by manually adjusting them from SQL Server by using different file groups, but this is quite complex to achieve because we need to move data around ourselves. Another way is to use storage that has this capability inside. There are all kinds of storage devices that have storage steering built in, and storage device itself will move data around based on the frequency of accessing and using the data. Okay, but again, for the sake of this demo, of course, I'm using my laptop, and I'm going to use all partitions on the primary file group. Okay. Now, I need to convert my single partition table to a partition table. There are several ways to do this. One way is to create a separate table with the same schema, which is it's empty in the beginning, and it's going to be partitioned. We will set up this separate table as a partition table using this partition schema, partition function. And then we can write a batch that copies the data from the original table to the new table. When we complete copying all the data, we can just rename the tables, and then we have a new table which is partitioned. This is going to be a very long process if we have a very large table. It's going to take a lot of resources for the server, and also if we want this operation to be online, then it becomes more complicated because we need to somehow track changes while we copy the data and maybe perform a union between the two tables. It becomes much more complicated. Another way to do it is to create another table, again partitioned, but we will have a single partition for everything that happened till today, and then we can simply switch the single partition from the original table to the single partition in the partition table. So we have one very large partition containing everything till today, and from today going forward, we will start having partitions per day. So this is a partition table, but for the history, for the past records, we have a single partition for everything. This will be a very simple operation. It's just a metadata change. It will not require a long process of copying data. It will not consume resources. But of course, if we want to access history and leverage the ability to archive all data day by day, we will not be able to do so because all the history is now in a single partition. So what we can do, another way we can do it, is we have a clustered index right now on the table. We are going to drop the clustered index, and then we are going to recreate it using the partition scheme. So while we recreate the clustered index, it is now going to be created as a partitioned clustered index, and of course the table becomes a partition table. And of course this is a very massive operation because it's a very large table. It will take some time. Basically we have a downtime of the table, so this is not a viable solution if we want the table to be online 24/7. We need some maintenance window to do this operation. Okay, but I'm going to demonstrate this approach. So I need to, I have a primary key, which is the clustered index right now. So I can't just drop the clustered index. I need to drop the primary key first. And then I'm going to add the primary key again. This time I'm specifying that it's a primary key, it's a clustered index, and I'm going to put the clustered index on this partition scheme with the date and time column as the partitioning column. Now, something that you need to bear in mind, that if you want to partition a table, you have to put the partitioning column inside the clustered index, the primary key in this case. So I have to add the date and time into this clustered index. Let's run this one. Okay, so it's going to take some time. Again, this is 5 million, so it's not really very large. In a much larger table, it might take a while. But once it's done, I'm going to run this very long query. Sorry about that. I didn't say before, but maybe it's a good time to say, I will make everything available for download right after the presentation in my blog. I'll remind that in the end of this session. So you'll have access to everything that I show you here. So this very long query accesses all kinds of system views in order to show us the partitions in the table after this operation. So now we can see that we have 182 partition. We created 181 boundaries. This means we have n+1, 182 partitions. We have the first partition is everything before we started to have data, before 6 months ago. And then we have partitions for each day. We can see the starting value of each partition. Everything is on the primary file group, of course. We can see the number of rows in each partition. If we go all the way to the end, so this is today. You can see that today the number of rows is smaller than the rest of the days because we're still in the middle of the day. Okay, and we have already a partition ready for tomorrow. And this is the current state now of the table. So from now on, every insert goes into the appropriate partition based on the date and time value. Okay, now let's talk about the archive operation. In this case, I'm going to, for simplicity, I'm going to just delete. I want to delete. I want to have a job that runs every day, deletes the oldest day, the 181 day before, and also prepares a new empty partition for the next day. Okay, and this is something that's going to happen every day. So what I'm going to do in order to delete the oldest partition and do it efficiently, I first need to do to create a table which has the exact same schema as my table, and not just the exact same schema in terms of the columns and the data types, but also in terms of indexes. It must have these exact same indexes. So I'm going to use the same primary key with the same columns as a clustered index, and I need this in order to be able to switch partitions. I call this web page views to delete. And then what I want to do next, I want to split the partition function. I want to add a new empty partition at the end of the table for the next day. Okay, so what I'm going to do here, I'm going to first, I go to sys partition range values to check what is the highest boundary value right now in the partition function. I'm going to show you this using this select. Okay, so currently, this is the date of tomorrow, the highest boundary, or the starting daytime value for the last partition in our table. And then I'm going to add 1 day for the next partition, and I'm going to split. Before I split, I have to run this statement: alter partition scheme next used. I must declare what is going to be the next use file group for the next partitions I'm going to create. Because as soon as I create a new partition by using the split method, SQL Server has to know if now a new row comes into the new partitions, where it should be located, in which file group. So first I need to say the next use file group is primary again, and I'm going to use the alter partition function, split range, and add the new boundary, the one I just calculated. Okay, so I'm going to run everything now. And if we run this BigQuery again, we're going to see that now we have 183 partitions, and we added just another partition for the next day coming after the tomorrow. So this is for the future, and for the past, what I'm going to do is I'm going to switch partition. I'm going to switch the second partition because the first partition is empty. It's prehistory. Okay, so the second partition is the oldest partition that contains data that I want to delete. And in order to delete it efficiently, I'm going to switch partition into my to delete table. Now the to delete table doesn't have to be partition. It's not partition right now. It's just a single partition table. And I'm going to switch the entire partition number 2 into the table to delete. And this happens in no time because it's just a metadata change. And then I can simply truncate the table to delete. And that's it. We deleted all the data. And now we are left with 2 empty partitions. Okay, the first one just like before. Now partition number 2 becomes empty as well, and we don't want to leave all those 0 row partitions. So the next thing to do is to merge the partitions. So again, I'm going to calculate the boundary value of the second partition, and I'm going to run a merge range operation on the partition function to merge the first 2 partitions into one. Because there is no data in them, so there is no need to move any data around. So this is again a 0 time operation. And let's look at the result now. Oh, sorry. Okay, so you can see now we have a single partition again for the prehistory. We start now from the 29 or 28, and just like before, we have 2 empty partitions in the future. So this is something I'm going to put inside a job. I'm going to run this job daily. Of course, we need to monitor the job to make sure it doesn't fail. We might want to create several partitions in advance for the next few days, and not just one at a time. There are all kinds of methods and approaches to that, but that's the general idea. And again, this has been around since 2005. A new feature in SQL Server 2016 allows us to truncate a single partition. So instead of creating a table, switching partition, and then truncating the other table, we don't need to do all that. We can simply truncate a single partition at a time in a single operation. So for example, here I'm going to truncate my table with partitions too. Okay, so I can truncate only the second partition, and this will replace everything that I did before, except for the merge, of course. I still need to merge the first 2 partitions. Okay, so now I do this, and that's it. It's done. I can show you again that we have now 2 empty partitions at the beginning, and I still need to merge just like before. I run the same code as before, and this is the end result of our partition table. Okay, so we have a single empty partition at the beginning. The second partition now begins at January 30. So this is how we should handle very large tables. We should partition them. Of course, this is an enterprise feature, and we are now able to very easily perform archives or delete for single partitions, and to manage data, including doing storage steering and things like that, like I mentioned before. So let me just get back to the slide. So table partitioning, like I said, facilitates the data archiving scenarios. You can optionally spread partitions between different storage tiers. It will help not only in archiving, but also in all kinds of maintenance operations, as we will show later, actually in the next part of this session. Things like rebuilding indexes, not the entire table, but partition by partition. And like I said before, it does not necessarily improve query performance. If you want to implement partitioning because you want to improve performance of your queries on the very large table, you might be disappointed. Okay, this is not a way to go. There are other ways to improve performance. We're going to talk about some of them later on in this session. Another feature that helps us manage table, which is a new feature in SQL Server 2016, is stretch database or stretch table. So in 2016, we can stretch our table to the cloud. We have SQL Server on-prem, and we have a local database here. And again, this is our very large table, and we have hot data and cold data. Okay, so let's say we consider the last 6 months as hot data. We want the last 6 months to be present locally on the local server, and all the rest of the data before 6 months is considered cold data. We need to be able to access the data only once in a while. So we don't need to hold all this data locally on our own storage. What we can do is to leverage stretch database to stretch all the cold data into the cloud, into an Azure SQL database. So we're going to set up an Azure Server and Azure SQL database, and then by leveraging this feature, we will be able to tell SQL Server to asynchronously all the time go and archive data, move it to the cloud. And the best thing about this is it's completely transparent to the application. Okay, so we don't need to change any code. As far as our application is concerned, we have a single table, and it's all local, and we can retrieve data from the table, whether it's hot or cold data. And if it's cold data, SQL Server will go behind the scenes, grab the data from Azure, from the cloud, and bring it to us. Of course, we're going to have some more latency in this case, but the idea is that we do it just once in a while. As long as we query the hot data, it comes from our local on-premise server, so it's going to be with better performance. I'm not going to demonstrate stretch database here, but I want to talk about it, how we set up stretch database. So if you think that this is appropriate for your environment, you can go ahead and start playing with it and setting up and testing it. So first, thing that I recommend is to run the Stretch Database Advisor. This is part of the upgrade advisor of SQL Server 2016. You can run this advisor, and it will analyze your current database and identify candidate tables to be stretch tables, and also identify all kinds of blocking issues, some limitations that you might have that will not allow you to stretch your tables. So this is the first thing you should do. Once you identify the appropriate tables and you know that you want to use this feature, so the next thing to do is to enable stretch database, or it's called remote data archive at the instance level using the spconfigure command. Once you enable that, you need to set up the Azure server. So you need to go and choose an existing Azure server or create a new one. Of course, you need to have an Azure account for that. And once you set up the Azure server, you need to configure the firewall in the Azure server. Most of the things here can be done through the wizard in Management Studio, so you don't really need to do everything yourself step by step. Of course, everything can be also done using T-SQL. So you need to configure the firewall rule in Azure to allow your on-prem server to connect and to access the Azure SQL database. The next thing you need to do is to create a database master key, and in your local database, of course. And you need that in order to encryption the credentials that it will use in order to connect to the remote Azure server. You need then to create a database scoped credential, which tells SQL Server how to connect to the remote Azure server. Again, this is going to be encrypted by the master key. The next step is to enable remote data archive at the database level, and this is where you're going to tell SQL Server on that database to which Azure SQL database to access and which credentials to use in order to access the database. Then when you go to the table level, now you identify a specific table in the database that you want to stretch to the cloud. You can optionally create a filter function. This is an inline table valued function in which you instruct SQL Server which rows are going to be considered cold data, which rows should be archived. And what SQL Server will do, it will cross-apply from the table to this function. And if the function returns a row for an existing row in your table, the row will be archived and transferred to the cloud. If not, it's going to be considered hot data, and it's going to be left in your local storage. You don't have to create a filter function. You can decide not to have a filter function, which means the entire table will be stretched to the cloud and will be stored only in the cloud. But still, it's going to be transparent. You're going to be able to access the table as if it was a local table. It's just going to grab everything from the cloud each time. So maybe you have a scenario where you already partition the table and you have one table containing only the hot data and another table containing cold data, and you have some mechanism that moves data around from the hot table to the cold table. So now you can take the cold table entirely, stretch it to the cloud, and have the stretch database feature do it for you, while the table still transparently appear to the application as if it was local. And the last step is to enable remote data archive at the table level by telling it which filter function to use, if at all. And also you have the option to configure outbound data. So outbound means data is going to be moved to the cloud. This is the normal operation, but you can also pause data transfer, and you can also specify inbound to move data back from the cloud to the local storage. And you will do this in situations when you need to set up things from scratch. You want to do some troubleshooting or maintenance and stuff like that. The normal operation would be outbound. All right, so this was about managing the table. Again, one option is to use partitioning. Another option, instead of partitioning, is to use the stretch database feature in SQL 7 2016. Julie, do we have any questions so far?
Yes, we do. One question was, is this an enterprise edition feature?
The stretch database?
No, on what that came in when you were discussing the partitioning.
Yeah, so partitioning is an enterprise feature. Actually, in SQL Server 2016, Service Pack 1, it became a standard feature. It's also supported in standard, but other than that, it's only an enterprise edition feature.
And another question, or really it's a comment from Martin, you said the partitioning table is not primarily meant to improve query performance. That's not
Right.
his own working experience. He's seen in many cases where partition elimination in large tables exponentially improves the response time, especially since SQL 2016. The query optimizers become efficient at reducing response time using partition elimination. So,
okay, that's true. So the concept of partition elimination is when you write a query against a partition table and you have a predicate, a filter on the partitioning column, SQL Server should be able to eliminate partitions and only access the relevant partitions to begin with, so it doesn't have to access the entire table or all the partitions. This is true in most scenarios prior to SQL Server 2016. This didn't work very well, and this is why in some cases you might end up in either worse performance as before, because instead of accessing a single partition, which is the entire table, you're still going to access the entire table, but doing it in many partitions, and it's going to be even worse. In 2016, indeed, there are some improvements, so partition elimination works better. And I agree that in some cases, you can still improve performance, and probably what this gentleman said is that in their case, it was very meaningful. And yes, this is great, but again, the goal of partitioning is not specifically to improve performance, but to improve the management of data and the maintenance of data. And even in 2016, there are many cases where you're still not going to see improvements in data. It depends on how you write your queries and what your business scenarios are. And like I said before, you still can see situations in which performance will even get worse as before.
Is there any index impact on the truncation of a single partition or on a switch partition?
So the idea of truncating a single partition is, again, it's a very fast operation. It's a minimally logged operation, not really deleting all the rows. And it's actually going to take all the indexes on the table. They all must be aligned, by the way. You cannot do this if you have a non-aligned index. And by aligning all indexes, meaning all indexes on the table are partitioned in the same way, SQL Server only has to drop the specific partition from each one of the indexes. So this becomes a metadata operation, and it's very fast. It does not impact performance or the indexes in any other way. It just drops the relevant partition from all indexes.
Is stretching tables a 2016 process only?
Is what? Can you repeat it again?
Is stretching tables a 2016 process?
Oh, yes, it's a new feature in 2016. You cannot enable it in previous versions.
Can we stretch a database to a different server on another cloud solution, e.g. AWS?
Not at this point. I don't know if it's going to happen in the future because, of course, Microsoft wants you to do it with Azure, but at this point, you can only do it with Azure, with an Azure SQL database specifically.
Have you seen table stretching work on a production environment yet? He loves the concept and just wanted to know how mature it is and how often other people are using it in the real world.
Unfortunately, the answer is no. I would really love to tell you, yes, I saw it in production, but not yet. I can't tell you how mature it is. It's a new feature, of course. We are working on some projects right now where we consider using this feature, and we're testing it already. I know some other that test this already, but I still haven't seen it in real production environment. No, not yet.
And what should you take into consideration when you are trying to choose the range for partition? Is having it daily with over 180 partitions really worth it? I don't know.
I'm not sure I understand the question.
I don't. I guess the first part, what should you take into consideration when trying to choose a range for the partition?
So whether it should be daily or monthly, for example?
That's what I'm guessing.
That's the question? Yeah, okay. So the main concern is how you want to archive the table. If you want to archive it day by day, you want to archive it month by month. How do you want to move data and manage data around? So if you want to work with daily processes, it makes sense to configure daily partitions. Otherwise, it will be something else.
Okay, that's all the questions for now. Thank you.
Great. Okay, so let's move on. Let's talk about how do we query the table. And I'm going to talk specifically about the ascending key problem. Okay, so let me set it up. So for the sake of this, the rest of this demo, I want to simulate the ascending key problem by doing the following. First, I'm going to delete the last week from the table. Okay, let's go 1 week into the past. Okay, we just invented a time machine. So we're now 1 week before. We just deleted the last week. And let's say that we updated statistics, okay, either manually or it was an automatic update statistics. Again, 1 week in the past. And after the update statistics, we now go again back to the present. So we insert rows for the last week. Okay, and I'll explain in a moment why I'm doing this. Okay, so this is the setup. So we had the last time statistics was updated 1 week ago. Okay, but we have data up until now. So now I have this test query. Okay, let's say that I'm using this current application. Let's say that our hot data is the last week. Most users, in most cases, query for the last week, although we have, in this case, 6 months of data. Maybe we have 7 years, but we need mainly the last week. Okay, so here I'm asking for the rows from the last week from the page views table, and I'm joining it to some other table, the reference codes table. And I need to include actual execution plan. Okay, so we get approximately 192,000 rows. And if we look at the execution plan, what we can see here, sorry, I need to show you first. We do a clustered index seek on the page views table and a nested loops inner join into the reference codes table, where we have another clustered index seek. If we go to the clustered index seek on the page views table, what we see here is the estimated number of rows is 1. The optimizer thought there is going to be only a single row in this table, while the actual number of rows is this, like I showed you before. Okay, so this is a huge gap, was completely wrong. And because it was completely wrong, it said, okay, if we have a single row, let's use nested loops. I'm going to perform this clustered index seek only once. But no, in reality, I'm going to perform this clustered index seek 192,000 times, which means we're going to have that much logical reads. Okay, again, multiplied. Let's say the table doesn't have 5 million. Let's say it have 5 billion rows. You get the idea. It's going to be very, very poor performance. Now, the reason this happens is because the last time we updated statistics was 1 week ago. So according to the histogram, the last date in the table is July 19th. So as far as the optimizer is concerned, in the last week, there are no rows. Okay, so this is why it estimates only a single row, while in reality, we had a lot of rows in there, but statistics was just not updated yet. Okay, this is the problem called the ascending key problem. It's very common in most databases where we have such large tables with the ascending date and time column. We will have the same problem, the same phenomenon. And the reason is that prior to SQL Server 2016, the threshold for automatically updating statistics by SQL Server is 20%. Meaning if we have now 1 billion rows, for example, and we have just updated statistics, we need to have 200 million rows to be updated or inserted before we have another automatic statistics update. And this is it's going to take a while, okay, probably more than a week. So we're not going to have an updated histogram for quite a while, and the optimizer will going to get it wrong and produce poor plans. Okay, so this is how it works by default prior to SQL Server 2016. One thing we can do prior to SQL Server 2016 is to use trace flag 2371. This trace flag changes the behavior of this threshold, the algorithm. It's not 20% anymore. it's a percentage that gets lower as the table gets larger. Okay, so with very large tables, we're going to have a much smaller percentage, meaning the frequency of update statistics is going to be better. We don't have to wait now a few weeks or maybe a few months until the next update statistics. So it's going to improve things a little bit. And in SQL Server 2016, this has become the default behavior. So if you use compatibility level 130, which is SQL Server 2016, you have the default behavior of this threshold, not 20%, but something that gets lower and lower as the table becomes larger. Now, what I showed you, I'm using SQL Server 2016, but I used right now for the demo the compatibility level of 110, which is SQL Server 12, on purpose, because what I showed you now is how SQL Server 2012 behaves, and of course prior versions. If we change it to SQL Server 2014 or 16, in this case SQL Server 2016, one of the changes starting with SQL Server 2014 is that now we have a new cardinality estimator. This is part of the optimizer. This is the component inside the optimizer that estimates the number of rows in the table using statistics. And prior to SQL Server 2014, it was the same component for many, many years. And one of the problems is the ascending key problem, where this component estimates one row because it thinks there are no rows in the last week. So there were some improvements starting with SQL Server 2014. We have a new cardinality estimator, and now when I'm using the new compatibility level, if I run the same query without changing anything else, we're going to get, hopefully, a much better plan. The same number of rows, of course, but now we have a hash match inner join. Okay, and if we look here, we now see that we have a much better estimation. It's not 100% accurate, but it's much better than before. Okay, it's not just one, it's a much better estimation. And now the optimizer knows it should use a hash match join and not nested loops. So we did that by just upgrading to SQL Server 2014 or 2016 and changing the compatibility level, not doing anything else. Now the optimizer does things much better. Now you have to be aware, this is very important, that with the new cardinality estimator, there are some drawbacks as well. There are some scenarios where you might get a worse plan than before, than with SQL Server 2012. And it's quite common actually with our clients. When they upgrade to SQL Server 2014, suddenly they encounter poor performance and they don't understand why. And it's because of the new cardinality estimator. So you might get better plans in some cases, you might get worse plans in some other cases. And in the cases where you get worse plans, it might be dramatic sometimes. So of course, what you need to do is to optimize those queries and improve them and make sure that under the new estimator, you get a good plan. But as an intermediate thing you can do, you can use trace flag 9481, which tells the optimizer to use for this specific query to use the old estimator. So although I'm in the new cardinality estimator, so the cardinality compatibility level, I meant to say, I'm going to use for this specific query the old estimator, which will produce the same nested loops as before. Okay, so for those queries where you see that they behave not as well with the new estimator, you can instruct the optimizer to use the old estimator query by query. Okay. Now, of course, if still we have a problem with the frequency of the updates, what we can do, and in many cases this is what we should do, we should create our own job that maybe runs once a day or once a few days and update statistics manually. Okay, we can control it to do it with a full scan, for example. If we run it for the full scan, it means we scan the entire table, we get a more accurate histogram, but this might take a while, it might consume resources. If it's really a very large table, this might be not practical. If I do that, so now we can see the statistics is updated as of today, as of the last value in the table. Okay, and now if we run the query again, we will get more accurate results. So we get the hash match again. Sorry. And now we can see that we have a much better value here. Okay. So we can use it with a sample rate. We don't have to use full scan if it's too resource intensive. But then with a sample rate, of course, it won't be as accurate, Maybe it's good enough, maybe not. You need to test it on your environment, but those are some options you can do as well. Let me go back to compatibility level 110, which is SQL Server 2012. And let's simulate the same thing again. Delete the last week, update statistics, last week, and then insert the last week again into the table. So again, since we're using 2012 now, without the trace flag 2371, we need to wait 20%. So we're going to have another update statistics on the table after we insert the last week. And let me prove it to you. DBCC shows statistics. Again, the last value is July 19, okay, a week ago. Okay, this was just to show you that we go back to the estimation of 1 with the nested loops plan. All right. So another approach, this is something we could do before, actually since 2008, is to use filtered statistics. And this works pretty well. Well, in some cases, it depends. What I can do here is I can create statistics on the date and time column, and I can add a filter, a where clause, only for the last week. So I want to create statistics only for the last week. It's going to be very, very small compared to the very large table, so it's going to be very fast to create these statistics. I can use full scan without fear, and it's going to be even much more accurate because it's just the last week. The problem is you get an error. We cannot use a non-deterministic expression inside the filter statistics, and this is a non-deterministic expression. Okay, so what we need to do is dynamically calculate last week, put it here as an hard-coded value, and then dynamically create the statistics. And this means that the filter statistic is going to contain the last week in every point in time. It's the last week now, but as we move forward into the future, it will contain more and more because it's just all the data since a specific date. Okay, so now if we look at the histogram, we have a much more accurate histogram containing only the last week. Now I'm going to run this query. Again, I'm still in SQL Server 2012 compatibility level at this point. I'm going to run this query. And I want to show you that it's not user statistics. It still thinks it's going to have a row. And another thing I want to do, if I use dynamic SQL with parameters, or maybe even a stored procedure with parameters. So you have here a parameter for the last week, sorry. Because we have parameters in here, SQL Server still can't use the filter statistics. So in both cases, SQL Server will not use filter statistics. In the prior case, when we did this, because of this expression, SQL Server can't use filter statistics. It has to have a deterministic expression in the query as well to be able to use the filter statistics. So this means we have to change our queries to use hard-coded values dynamically. And in this case, when we have parameters, SQL Server has to produce a plan and put it in the plan cache so it can reuse the plan for different parameter values. And since it cannot guarantee that for each parameter value, it will be able to use the filter statistics, it will never use filter statistics when parameters are involved. So what we can do, if we change our code in the application, and then in the query, we're going to use a hard-coded value, which is contained in the last week, then now SQL Server can identify that it has a filter statistics covering everything it needs, and it can use these filter statistics and produce a very accurate, actually this is an exact estimate. Okay. We can use trace flag 9204, which is undocumented. This trace flag will show us which statistics were used in the optimization process. So this way we can make sure that we are using the filter statistics. If we look at the messages, okay, then here it is. We have the filter stats loaded, so we know that we use the filter statistics. And if we use the non-deterministic expression as before with the same trace flag, we will see that in this case, where we get the nested loops plan, we are not using the filter statistics. Okay, so it does not appear here. Now, if we go back to SQL Server 2016, in 2016, now I run the same query which has a non-deterministic expression. One of the improvements in 2016 that SQL Server can handle those situations, and even if the expression is not deterministic, SQL Server can use the filter statistics. It can identify that the actual value is contained within the filter statistics, and it can use the filter statistics. So this is something that is new in 2016. And if I want to prove it to you with trace flag 9204, then unfortunately, we will see that nothing happens with this trace flag. So this trace flag is not supported in 2016, and I guess this is a good demonstration of what undocumented means. Okay, but don't worry, we have another trace flag 8666. We're going to enable this trace flag and run the query again. And what this trace flag does, it adds debug information to the query plan. So now I can go to the select operator, go to properties, and here we have internal debugging information. Okay, so I'm going to show you now because it's quite ugly, but somewhere in this text you can find the statistics used, and you can identify. You can just search for it and find the filter statistics being used in this query. Okay, so this is if you want to make sure that it was used. Let's turn off this one. And also in 2016, if you use parameters like in this batch or in the store procedure, then this is again something that SQL Server 2016 can handle. It will use filter statistics, and if you're going to use a value that is not contained, it will recompile the plan and generate a new one. Okay, so again, we have a good estimation here, and we have a hash match in this case. Let's drop the filter statistics. And let me summarize what we did today, and we'll continue the rest of the demo in the next part of this session on August 9. Okay, so if we go back here, so this is the ascending key problem, and some solutions we saw to this problem is to update statistics manually with a job once a day, once whatever, either with a full scan or with the sample. We can use trace flag 2371 if we use a version before SQL Server 2016. In 2016, this is the default behavior. The new cadenarity estimator, which can do magic in some cases and improve performance and the plans, like the case of the ascending key problem, be aware that it can also make some query plans worse than before. You need to be aware of that and test your application when you upgrade to SQL 7 2014 or 2016. And we can also use filter statistics, as I just showed you. Of course, with filter statistics, since we only use deterministic expressions, now we need to have some maintenance job that runs daily or maybe weekly and replace the filter statistics with a new one for the last week again and again. Okay, we can't just create it once and it will not contain the last week, it will contain more. So we need to maintain this solution. Any questions?
There's just one more question, Guy. The auto create statistics is on by default on their system. He's just wanting an understanding of why we're updating the statistics again manually.
Okay, so by default, the database is configured to update statistics automatically. And like I said, before 2016, the threshold is every 20% rows changes in the table. And it might take a long time until the next time statistics are updated automatically. So maybe we want to increase the frequency, and in order to control that, we can create and manually do it, let's say once a day. Another reason is that by default, the automatic update statistics of SQL Server is done with the sample of the data and not full scan. And if we want to update statistics with a full scan to have more accurate histogram, then we can do this with a manual operation.
And that's it for questions. Again, I'd like to remind everyone that this broadcast was recorded and will be posted on the DBA Virtual Chapter archive page. And please join us on August 9th. It's noon Mountain Time for part 2. I hope to see you there. Guy, we really appreciate your time on this. Excellent
Thank you very much.
presentation.
Again, I'm going to upload all the materials to my blog. It's right here on the slide. So check it again in a few hours or maybe tomorrow, and you'll be able to download everything from there.
Take a picture. Thanks again, Guy. And Guy, if you want to send me either the slide deck or this information, I'll then try to post it also to the website.
Excellent. Great. Thank you very much.
Thank you, everybody, for attending, and we'll see you on August.